Hi, thank you for watching this demonstration video on the short takeoff with stoval flaps in the AV-8B. So in this video I'll be covering off the concept of what the short takeoff is and why it's used, and the differences between the stoval and auto flap type short takeoffs. And then I'll go into the pre-takeoff data assignment and I'll point out some key differences between shore and bow based operations. And then we'll go into the one finger checks followed by the short takeoff itself. So the short takeoff is the most common type of takeoff that you can expect to do in the AV-8B Harrier. It allows you to take off with approximately 800 or less feet of runway for a reasonable mission loadout at sea level with what would be considered a fully laden Harrier, not considering sort of overweight loadouts such as all of your pylons being full of triple racks of bombs. Most of those loadouts are now restricted anyway. So the main difference between the auto and the stoval flap short takeoffs is that the auto flap short takeoff is used when there's a concern of FOD on the runway or around the prepared surface that you're using. Obviously in the real world this is a serious issue, and any rocks or bits of debris kicked up by the engine can hit the flaps and damage them. So sometimes in the real world they use the auto type flap short takeoff. In DCS that's not simulated. FOD is either debris that is on the area that you're using, in which case if you touch it most likely your aircraft's either going to break or it's going to blow up, or it just isn't present at all. So we always use VSTOL type short takeoff. First of all, what I'm going to do is I'm going to do the cockpit setup so that I'm ready to go. It's what I like to do first of all when I get in the aircraft. So I've turned up all my brightness knobs. I'm going to set the altimeter to read 0 on the ground. Remember not to overscroll because it will stay at 0 even though the pressure that you're setting is decreasing. And then after you take off, it will take longer for the altimeter to come alive, and it might say that you're at 500 feet when actually you're at 1,000, for example. Remember that we only use QFE at FOBs for training purposes. If you're operating out of an airbase, the control will probably give you the QFE. However, if you're departing straight out, most of the time you stick with the QNH anyway. If it's an unrestricted climb out, any other type, say just a straight out or a turn or a visual circuit departure, you need the QFE. So yeah, if you're going between FOBs and FARBs, stick to the QNH and just remember what the field elevation is. Next I'm going to set up my EHSD, so I'm going to turn the gain down so that's a bit more readable in VR. Come into the map, I'm going to zoom in so that if we do any visual circuits, a bit easier to see. We're going to put colour to red as well. It's just personal preference, and we hit map M again. Then we put the course line in, which is going to be 246 degrees, as read there. So hold that and then type it in on the scratch pad and hit enter. And then coming down and to the left, obviously we're on the runway already, so we're okay to put all of our lights in the position that we want them. And I like to raise my seat slightly for takeoff and landing and then lower it back down for the rest of the flight. Okay, pre-takeoff data assignment, so fairly straightforward. I'm going to demonstrate how to do it for a shore-based procedure. So on the left-hand PCD, let's open up the VRES page. We'll straight away change the basic aircraft weight and overwrite it with the operational weight, which is 16,475, and the BDI, which is 16. Okay, and then we're going to go straight into the stow option. Gross weight we don't need to touch. Outside air temperature is 29 degrees C, so we're going to edit that. Again, remember that if you're inside a hangar or if it's a different time of day, it may read a lower outside air temperature than whatever's set in the mission. Always use whatever's set in the mission because you always want the higher temperature, because that's going to give you worse engine performance, and you always want a conservative estimate of takeoff performance so that you don't reach the end of your given prepared surface and find out that you can't take off and crash. Field elevation would be 94 feet, but in this case, because we've got the QFE set, we're going to set it to 0 because it's going off the altimeter. Next is the field data, so the runway distance is 4,100 feet, which is actually quite a lot for the Harrier. Again, you're normally looking at about 1,000 feet for normal operations. Next is the runway heading, which is going to be 246 degrees. And then, of course, we've got the ground wind, which is 338 at 009. Okay, so looking at our values here, we first of all want to hit a boat in the bottom right, which is that one, and then we get an abort speed. So we know that if we're taking off and we reach 104 knots, that's basically our decision speed. If we want to reject the takeoff on the ground, we have to do it at that speed. Otherwise, we either need to eject or we need to commit to the takeoff and eject once safely away from whatever obstacles there are, or try and recover it if able. Today we're going to go with dry values, so we're going to go with an NRAS of 73. So if we just hit the VSTOL master mode there, we can see that now on the ODU we've got NRAS in pitch carats, so we're going to set NRAS to 73. This means that when we accelerate up to 73 knots, a box will appear around the knots indicated airspeed in the hood, which is shown on the left hand side there, and is always set at 30, by the way. And that's the point at which we bring the nozzles back to the stow stop. So similar in principle to the noseway liftoff speed, except you touch the nozzles and not the stick. Nozzle setting is going to be 60, so we'll move on to one finger checks in a moment and we'll go through that. So a brief description of what's different between the shore-based and the boat-based or carrier-based procedures. So on the shore, your runway is a fixed heading. On a boat, the carrier is going to point into wind. So when you're on a shore-based procedure, you put in your field data, you read the numbers, you perform the takeoff, and you don't need to touch it again because, for example, things like the wind and the air pressure, etc., are all going to be the same, and your performance for, say, the cruise is going to be based off those figures. When you're operating from the boat, now in the real world, there would be someone, I'm not sure whether it's in the tower or in one of the briefing rooms, would actually have today's weather information, the boat's information, so it's pointing to wind, what's the wind over deck, so on, and then it'll have your aircraft's information of what stores you're using, and they will manually plot what your takeoff performance is going to be, and then they'll decide what configuration you need to take off. They'll send that back up, and one of the deck operatives would hold up something called a tote board, and that would basically tell you, do you need water, what's your NRAS going to be, stow stop, and what distance do you start the takeoff at? Because on the boat, you don't go off NRAS, you go off the nozzle rotation line, which is toward the front of the boat. So if you need less space, they will taxi you further forward on the boat, so that they can operate behind you and taxi their aircraft out and so on. In DCS, it's more likely that you can line up with your squadron mates and then you're going to take off. In such a case, you need to know whether or not you have the performance to do so, and we need to do it through the VRS because we don't have that capability. So what you would do is you would put in the carrier's information, which is, if I come back in the stow, I'd go in FDAT, I'd make the runway distance, say 800 feet, I'd make the runway heading, the heading that the carrier is going, which should always be into wind, so today it would be 338 degrees, and then the ground wind, I would make, obviously, the heading of the wind, so 338, and then I would make it the wind speed, the wind over deck, and then when you read these values, it will obviously give you your NRAS, your nozzles, and then the ground rules, the most important things. So you can see here, 423 feet for wet, 538 feet, so you'd know what distance you need to start the roll from. However, you would always, on the boat, use a 60-degree stow stop, and you would always bring the nozzles back to the stow stop when you meet the nozzle rotation line toward the front of the boat. Okay, so enough talking, let's move on to one finger checks. So coming back into the left, first of all I'm going to bring the nozzles all the way back, and then I'm going to bring the stow stop forward to 60 degrees, and then I'm going to look over the front and check that it stops at 60 degrees. The reason I do that is it just means I don't have to do it twice. Now I'm going to bring the nozzles forward and set them at 10 degrees. Perfect. Double check the lights, they're all fine. Coming forward, nose wheel steering is going to be in the anti-skid position. Flaps are on and they're going to come down to the stovel position. Combat water is going on. Because I'm demonstrating the dry maneuver, I'm not going to put the water to the takeoff position. If you are particularly heavy, You want to use takeoff water if it's over 20 degrees Celsius outside. If you're fairly lightweight, like I am today, only carrying some AIM-9s and a gun pod, don't bother using the water, save it for when you land. Okay, and then of course you would put your NRAS value in, but we've already done that. Perfect. So on the left MPCD, we're going to open the HSD, which is already set up the way we like it. Bring the scale down to 8 and down to 3. And on the right MPCD, we're going to open up the hood, just in case we fly in the sun and we don't have the ability to see over the hood in front of us. Okay, so let's talk about the takeoff. So the parking brake's off. To perform the takeoff, I'm going to hold the brakes, I'm going to advance the power to full, and I'm going to hold the nose wheel steering button. At the wheel skid, I'm going to release the brakes and allow the aircraft to come forward. Until the airspeed indicator comes live, I'm going to hold the nose wheel steering button. I'm then going to release it at roughly 45 knots. That's when aerodynamic effect of the rudder takes over. I'm going to continue to accelerate up until the NRAS. At the NRAS, I'm going to bring the nozzles back to the slow stop, which is 60 degrees. I'm then going to use the capture attitude technique to begin a transition from semi-jet-borne flight to wing-borne flight. At 25 degrees nozzles, I'm going to pause. I'm going to bring the power back slightly. I'm going to bring the gear up. I'm going to bring the flaps up, then the gear up. Then I'm going to program the nozzles fully forward. Then I'll do my touch checks, which is stow stop and water. I'll then re-add the power and fly until about 250 knots, at which point I'll put the flaps into cruise. I'll switch into nav mode. I'll continue to fly until I reach 300 knots, and then I'll pitch up for the 300 knot climb up. So I'll demonstrate that now. Holding the brakes, let's advance the power. Holding the nose wheel steering. There's the skid, release. And maintaining runway center line. Release then WS, NRAS, capture attitude technique. Nozzles forward, there's 25. Power back a little bit, flaps it up, and we're still good. Gears coming up, and we're good. Nozzles coming forward. Stow stop's clear. Water's off. Power back on. Into the nav mode. Check my runway center line. And flaps into cruise. And we're looking for 300. There's 300 knots. And let's start our climb out. And 9,000 feet, let's bring the nose down and bring the power back a little and bust the altitude slightly. Trim the aircraft. I would normally set myself back to the QNH now after the climb out, and I would continue with my flight as normal. I hope you found this video useful. The key notes to take away from this are obviously the differences between the shore and the maritime-based procedures. The shore ones are very simple because you just set the field data, you read it, you perform the takeoff. The maritime ones are a little bit more complex because you're actually just trying to solve for the available ground distance, and then you have to redo your field data so that you've got accurate cruise information. Remember that it actually happens in really quick succession. I was struggling to actually verbally stay ahead of what was happening there, but it's simply hold for the skid, release the NWS, NRAS, capture attitude technique, program, do your cleanup, program forward to 0, do your touch checks, and then transition for the climb, perform the best climb at 300 knots. If you have any questions about anything you've seen today, please feel free to contact me. Thank you very much for watching.